Jain friends, myself is Nikhil Kumar, faculty of IT department in AKGEC Engineering College. Today we have a lecture on algebraic structure. Basically, algebraic structure is the fourth unit for the BTech second year CSC and Allied branch in DSTL, Discrete Structure and Theory of Logic subject. And the topic we have covered in this lecture, that is the algebraic system and general properties, semigroups, monoids, groups and subgroups. The basic term and from the very beginning, I am tell that there are some points that we noticed that the term n is a representation for the natural numbers, and z is the set for the all integers number, q is the rational number, and r is for the real numbers representation. Basically, these are the terms that are the standard way to represent the term in DSTL, Discrete Structure and Theory of Logic content. What is the binary operation? The binary operation is said to be an operation, or an operator is said to be a binary operation that it is closed under a non-empty set. For consider that there are two elements, two identity A and B are such that consider in a set value, suppose L, and these elements are covered under a operations that are the strict. So in such a manner we can describe it in such a way. Here a strict is used as a operator, that is the binary operator. So some are the properties that are covered in this. What is the algebraic system? A set A with one or more binary operations, that is the closed property, and some other property that I will discuss in the next slides, that are the algebraic systems. So basically, algebraic system is a system where some binary operations are covered in a system with the properties that are commutative, associative and identity. So basically, from the first stage I will define what is the commutative law and other some law, so that the concept will be clear. The commutative property says that strict be a binary operation on a set A, value A. The operation strict is said to be commutative in A if A strict B equal to B strict A. Basically, for the operator purpose, we here in the DSTL and basically in the algebraic structure, we will use the strict operations. It is basically a representation for the operator, so that for different commutative, associative and different laws, we can use strict. It is represented as strict. So in the commutative laws, A star B equal to B star A, that means the sequence of the elements, if changed, then the values, the output value will not be changed, so that the element A and B also exist in the capital A. Here it is very important to know for all the students that when we represent the set value, to represent any set, we always use the capital words, capital characters, that is characters A, B, C or X, Y, Z. But when we use or represent the elements for the set value, for the set elements, then we always use the lowercase, that is A, B, C or X, Y, Z in the lowercase. The second law is associative law, where it can be represented as A star B star C equal to A star B star C, so that it is represented in such a manner that firstly we will calculate A star B, then the output for that operations we will conclude A star B star C. But in the right side, firstly we will conclude B star C, then the result we will conclude A star B star C. Okay, and I am very, it is very important to know that what is the star value. Star value is the basically operations. It can be changed, plus, minus, division, multiplication, or some other operators. Basically, here in DSTL, star is just like a operator value. It can be changed question to question. What is the identity? Identity is a value for the set elements, so that such that the for the all set values, the identity value will be fixed. That is a unique value. For example, for an algebraic system, A star, A comma star, that means here A is a star set elements and star is the operative. An element E in A is said to be an identity element of A if A star E equal to E star A, that equal to A. That means the value of the element will not be changed after the operation is performed with the element's value. So such type of element is called the identity element. And the other thing is that element is also present in the set elements. For example, if we represent such scenario in a example, let's suppose there is a set element A with the element 1, 2, 3, 4. Here, if we represent or we identify that the E is a identity element, that is the 1, so that when we apply the operations in the set values with the identity element 1, so that the values will not be changed after the apply the operations. So such elements is called identity elements. Here, if we apply the E star A equal to A, that is the commutative laws that we already discussed. Here, if we can say that E is equal to 1, we have already decided. Okay. So, for if we use star as a multiplicative operations, that means A into E equal to E into A will be A. So that the element A can be represented from one of the elements from the set value capital A. Here we take the value 1 into, for the element A we take the value 2. For the element E we take the value 1 into 2 equal to, always with the value contain the value, that is the A. If we take the value, here I take the value 2. If I take the value A equal to 3, then the element that it can be formed as 3 into 1 equal to 1 into 3, always with the value same, that is a 3. So that for the all the value of the set elements, the identity element will be fixed and unique, so that the value will not be changed. For the note, for an algebraic system A comma star, the identity element if exists, then it should be unique. For the same question, if we take the operations plus, okay, addition operations, then such case the value will be 0. For the operations E equal to 0, suppose that the element are set values 0, 1, 2, 3, 4. So here the identity element will be 0 for the case of the operation case, so that when we add in the set elements the value 0, the value will not be changed in any case. What is the inverse? Inverse is contain a value in such a manner that every element contain such a value, such other values, so that A into B equal to B into A equal to E. If such scenario exists, so we can say B is a inverse value for the element. B is the inverse value for the element A, so that the value will not be changed. That means the A into B. That means that if we apply the operation with the elements and other elements, then the element B will called the inverse of the element, so that the value will be after apply the operations, the value will be the identity elements. It will be clear after apply some examples. In the next slide, we will discuss all about that. What is the semigroup? Semigroup is a group which contains some properties, or we can say it is an algebraic system. Actually, it is represented in the form of A, star, where A is the algebraic system and star is the operations that we have already discussed in the previous slides. The semigroup is a algebraic system that have some properties. What are that properties are? That means the first property is it should be covered, that is contain the closure property, and second is the associative property. What is the closure property and associative properties already we have discussed. That means if there is a set A, with some element, let's suppose A, B, C, and we apply some operations, that is the suppose the operations is the multiplicative. So after apply all the elements on all the elements, if the value will not change for the, that means after apply all the after apply the operations on the multiplicative, the resultant value is also considered in the set values. That means then values not differ from the set values that is covered in the set elements. That is the closure property. It is also called closure property. The semigroup contains two properties of the algebraic system. First one is the closure property and second one is the associative property. Associative property contains, that means the order of the element is not changed after apply the operations. That means it is the associative property. Or in case of closure property, that means after applying the operations, multiple operations in the algebraic system, the values, the output values also exist in the algebraic system, then it is called the closure property. And what is the monoid? It contains an extra property, that is the identity property. Closure and associative also present in the semigroup properties, but an extra features, that is the identity element, is also exist in the monoid. Okay. So there is just some example. So that the set N. What is N? Basically, if there is not mentioned in any questions what is N or Q and the different things that are or are that already defined in the previous some PPTs, then it is very clear to know for all the students that always we use the capital N for the natural numbers. Okay. If it is not mentioned in the question, by default we take the values N as a natural number. So for the case of the monoid, the what is the property that exists in the monoid? Monoid contains the closure property, associative property and identity property. That means the natural number N, that means that contains the value 1, 2, 3 and 4, and so that The identity element are the element that are exist in the set values, are such elements are considered that the identity element that after applying the operations on the set elements, the value will not be changed. So that here in that case, the operation are the multiplication. Okay, a dot 1 equal to 1 dot a. That means the value will not be changed after applying the multiplication in 1. We know that all the numbers are have the property that if we multiply in 1, the number will not be changed, number will be same. So that it is a 1, a, and it is the same and also exist in the natural numbers. So that we can say it is the identity. Identity element for the multiplication is basically, and for most case is already exist 1, and the identity element are also the elements that are unique for the all the values of the set elements. But in case of the inverse value, it should be particular, different, and vary from elements to elements. The next term is the sub-semi group. Sub-semi group. What is sub-semi group? Let S comma star be a semi group and let T be a subset of S. If T is a closed under operation star, then T comma star is called a sub-semi group of S comma star. Basically, sub-semi group is just like a subset of the set values with the values with the set elements semi group. For example, n comma dot is a semi group and T is a set of multiplication of positive integer m, then T comma dot is a sub semi group because it contains all the features of the semi group. All the elements that are considered in the semi group have a particular and a subset value in the sub semi group. What is a submonoid? Let submonoid is the let S comma star be a monoid with identity element E and let T be a non-empty subset of S. If T is a closed under the operation star and E belongs to T, then T comma star is called a submonoid of the S comma star. The most important topic for DSTL and for the algebraic structure is group. What is the group? An algebraic system G comma star is said to be a group if the following conditions are satisfied. Basically, a group contains some features. If some features are provided in a set elements after applying some operations, then we can consider or we can say that this algebraic structure is a group. The very most important properties are 1, 2, 3, 4. First one is the closure property. That means after applying the elements, after applying the operation on the some elements value on a set elements, if the elements the resultant value also exist in the set elements, then it is called the closure values. That is the closure property or closure elements. If such elements exist in the set value, that is the closure property. That is the first one. The second one is if the elements of the set values contains the features of the associative law, then it also exists in group. And third one property is the set elements contain the identity element. And the fourth one is every element in G has the inverse in G. That are some interesting point. The identity element and the inverse value. The identity element for and the set value are fixed and unique in nature for all the element for exist in the set element. But For the inverse value, every element that exists in the set contain the inverse value that is unique for elements to elements and varies from elements to elements. What is the abelian group? A group is said to be abelian group if it contains the features of the group and also some other some extra features, that is the commutative properties. That means a group is called the abelian group if it contains all the features. That means 1, 2, 3, 4 points contain in the contain the properties and also contain one extra features, that is the commutative group. A group G, star is said to be abelian or commutative if A into B equal to B into A, where A and B are the elements that exist in the set A, and here in case example dot are the operations that I use in the to represent such abelian group properties. For the till this slide we have considered what is abelian group, group, monoid, semigroup and algebraic system. All the structure are considered the algebraic system. Abelian group are the contains the features of the group and one other property, that is the commutative laws. That is, and group contains the 4 features that we already discussed in the last previous slides. Monoid and semigroup also we have discussed. The next one is important theorem. In a group G, star, that means the operations, the following property hold good. What we have discussed, that look, identity element is unique, we have already discussed. For the set value, for the particular set elements, inverse of an element is unique for elements to elements in a set value. Cancellation law hold good, that means if A star B equal to A star C, so we can say that A will be cancelled out from these expressions from the left cancellation law, where star is the operations because AR is common in both the terms. So, but in case of A star C equal to B star C, C will be cancelled out. It is the right cancellation law. It will also be discussed in next some slides. A star B inverse can be used in the term B inverse into strict A inverse. What is the order of a group? The number of elements exist in a group is called the order of the group. And what is the finite group? A group is said to be finite if the number of elements that exist in the group or set value are limited and fixed, and we can consider in the terms of mathematical terms, we can define the number of terms, that is the finite group. Then that group is called finite group. Okay, this is a very important question. So that the set of all integers in a group with respect to addition is abelian group. In such type of questions, we have noticed that there use set of all integers. Integers are represented as the elements Z, the particular capital Z. If closure, associated, identity, inverse and commutative properties are fully satisfied with these questions, then we can say that this is the abelian group, because starts 1, 2, 3, 4 properties also exist in the group, but fifth one, commutative laws, is considered only the group property, that is the, then if all the 5 elements of properties are satisfied, that is called the abelian group. So thank you class.